The first colligative property that we're going to look at is vapor pressure. So for vapor pressure, we will be using Raoult's law, and this law says that the vapor pressure of a solvent is proportional to its mole fraction in solution. So if you had pure solvent, it is, right, it's 100% that solvent. The number of moles of solvent that you have, the solvent is the only thing, that's also the total. So the vapor pressure is just whatever you looked up. It's 100% that solvent. So when we start dissolving other things in solution, this is when we have to deal with Raoult's law. And so what this says in equation form is that the pressure over the solution is equal to the mole fraction of the solvent times P0 of the solvent. So the P0 of the solvent, that's the vapor pressure of the pure solvent. So if I go to a vapor pressure table, I look it up for water, that value. And then the mole fraction of the solvent, this is the way that we're communicating the concentration. And it specifically has to be for the solvent. If you multiply those together, you will get the vapor pressure over the solution. Okay, let's look at this with an example. We are going to calculate the vapor pressure over a sugar water solution prepared by dissolving 100 grams of sucrose, which is a non-electrolyte, in 100 grams of water at 20 degrees. The vapor pressure of pure water at 20 degrees Celsius is 17.54 torr. So this vapor pressure of pure water, this should match what's listed in the appendix, which is a part of your equation sheet. There is a vapor pressure table for water in there. So I need, that's my pure vapor pressure of the solvent. I need the mole fraction of the solvent. So the mole fraction of the solvent is the number of moles of solvent over the total number of moles in the mixture. So I need number of moles of water divided by number of moles of water plus number of moles of sugar. The number of moles of water, 100 grams, you should practice this, check your conversion, you should get 5.549 moles. So 5.549 moles of water divided by that same value plus this 100 grams of sucrose should come out to be 0.292 moles. When you divide those, you get 0.95. So, right, it's not a lot of sugar dissolved in 100 grams of water, so it's like 100 mils of water. Right, it's still mostly water. It's still 95% water based on our mole fraction calculation. So the vapor pressure over the solution is 0.95 times the 17.54, which was the pure vapor pressure. So the vapor pressure over the solution goes down as you dissolve more things in it. Okay, second example. If we have a solution with 0.102 moles of calcium nitrate and 0.927 moles of water, calculate the vapor pressure of the solution at 55 degrees, and then I have assume complete dissociation of the solute. This means assume it's a perfect world for your Van't Hoff I factor, really. But our equation didn't have a place for I. So in vapor pressure, this is where we will have to kind of take care of it for ourselves. I am still going to do the calculation of I so that you can see it with this, but you'll see where these things show up as we do the other parts of the calculation. So at 55 degrees Celsius, the vapor pressure over pure water is 118.1 torr. So I have my pure vapor pressure. I need the mole fraction of my solvent. And this means moles of water divided by total moles. Well, the total moles, my things in solution are water and calcium 2 plus and nitrate, right? If calcium nitrate is dissolved, it's an ionic compound. It is split up into its component ions. and you get 1 calcium and 2 nitrates every time one of those split up. So really, right, if I did this as an I factor calculation, I get 1 calcium and 2 nitrates. That's 3 things for every 1 mole of calcium nitrate. That's an I factor of 3. So that's a pretty large I factor. Now, where this shows up in my mole fraction calculation is for accounting for each of these. I've got N calcium 2 plus and 2N nitrate written here, right? Because for every 1 mole of calcium nitrate, that's what I get. So in my mole fraction of the solvent, there's 0.927 moles of water. And then for my total moles, there's 0.927 moles of water and 0.102 moles of calcium 2 plus and 0.204 moles of nitrate, right? So water plus calcium plus nitrate to account for everything. So this makes the mole fraction of my solvent 0.752. So because the solute that I'm dissolving splits up into more pieces, it lowers the mole fraction of the solvent and lowers the vapor pressure even more. So 0.752 times that pure vapor pressure gives me a vapor pressure over this solution of 88.8 torr.